Hi folks, this is a quick video to go through the actual calculus test, even though it says formative, so that probably tells you how similar they are. Um, so if we're finding a limit, we just sub in. So if I put in -2 here, I'd have 2 times -2 squared plus -2, which would be 2 times 4 minus 2, or 6. There we go. Next one, we want to find the limit as x goes to 1. If I put in 1 here, I'm going to get 0 over 0, which tells me I should try something else. So I'm going to factorize the top. I'll get lim as x goes to 1 of x by x minus 1 all over x minus 1. Those x minus 1s will divide out, and so I'll have lim as x goes to 1 of x, which is just 1. The next one, I think we'll have the same issue. We'll get 0 on top, and let's see, on bottom. On top, we'll get 16 minus 12 minus 4. Yep, 0 over 0. So what we're going to have to do here is try and do something fancy because substitution failed. So I'll have x plus 4, x minus 1. And if I had been smarter, I probably would have made one where it was the denominator that remained, but that's not the case here. So we're left with x minus 1, and now you can sub in -4 minus 1, or -5. Moving on, write the equations of the horizontal and vertical asymptotes in this. So the vertical asymptote makes the bottom 0. So let's think about that. What makes 2x minus 3 equal to 0? You might just see it and call it 1.5. If not, we can solve this little equation. There we go. So the vertical asymptote is x equals 3 over 2, or 1.5. Makes the bottom 0. That's our definition here, and doesn't divide out. For our horizontal asymptote, we're going to consider the limit of the drivers. And it's okay if you do this informally, if you just look at the drivers and divide them out. But it's 4x over 2x. Those x's divide out, which would be the lim as x goes to infinity. And it's the same on either side, of 4 over 2, which is 2, which gives us 2. You do have to write that the horizontal asymptote's equation is y equals 2. So y equals 2, and x equals 3 over 2. Moving on, we're going to find a derivative using first principles. So here we have f of x is 2x squared minus x. We know that the answer here should be 4x minus 1. Let's tell the story of how we get there. So I'm going to find f of x plus h by subbing in. Remember, anytime I sub in, I should use brackets. That's going to give me 2x squared plus 2xh plus h squared minus x minus h. Or 2x squared plus 4xh plus 2h squared minus x minus h. All right, at this point, we're going to go ahead and sub in. So f prime is equal to the limit as h goes to 0 of f of x plus h, which is what we found in red, 2x squared plus 4xh plus 2h squared minus x minus h, minus f of x. So that needs to go in brackets. And one of the big lessons here that we're reminded of is that when you substitute in, stuff needs to go in brackets. So let's see what we can do here. I would do my cancellation in 2 steps here, this subtraction that can happen. And then I'll worry about the division, because true division in fractions should really only happen after we factor. Okay, so you might be inclined to divide out some h's here, but beware, it may lead you down a bad path at some point. It is safer and more correct for us to factor, divide out our h's, and then we're going to have 4x plus 2h minus 1. And then, of course, as h goes to 0, that 2h becomes 0. We're left with 4x minus 1, which, frankly, we knew was going to be the answer all along. Next one, differentiate. We can do this in pieces. So 2, 5x to the 4. You don't have to show that. Minus 3, 3x squared, plus 4 by 1, minus 0. It is fine if you just skip to the end here. 10x4 minus 9x squared plus 4. Okay. And I'm doing this as my first pass for the solution, so hopefully I haven't made any goofs. In B, you'll probably think of this as 10x to the half minus 5x to the minus 3. Okay, so that means y prime is 10 stays as a coefficient, 1 half x to the minus a half minus 5. This comes down front. Remember, the power goes down by 1, so it's negative 4. Okay, so we'll get 5 x to the minus half plus 15 x to the negative 4. If you want to show that in radical form, we'd get something like this. And there are some tricks you can use to easily differentiate x's on the bottom and square roots, but safest thing is to go to that kind of exponential form. Next one, 6x cubed minus x all to the half. Okay, that's what this means. In other words, it's a glob. It's a glob to the half. So as I differentiate, I'm going to have 1 half glob to the negative 1 half times the derivative. There we go. Okay, so pictorially, that's what's going on. Let's just sub in what we know these things to be. The glob does not change. And then this is going to become 18x squared minus 1. Okay, so that's going to give us 1 half. It's frankly probably okay the way we just had it there. 18x squared minus 1. 6x cubed minus x to the negative a half. Or in radical form, 18x squared minus 1 all over 2 root 6x cubed minus x. Okay, either one's fine. This is good. This is good. Next one, we got a quotient rule. Yay! So the top is 2x minus 3. Its derivative is 2. The bottom is 3x plus 1. Its derivative is 3. Okay, and we have u prime v minus u v prime all over v squared. Let's do this in blue. And my gripe here with the Apple Pencil, my one gripe, is that I wish if I just clicked a color, it would automatically send me back to the pen. This whole 2-click thing for a company that, does amazing UI. Not cool. Anyways, that's a real aside. And a nitpicky thing on a transformational piece of technology. Okay, so I'm just killing time by saying these things because I'm going to do all my math here. So I have 6x, I have negative 9. I multiplied by 3, but I'm subtracting it all. So that's why I kept the brackets in this step. Okay? And that's a common mistake, is to forget that you're subtracting it all. So when we actually work it out, that's a positive 9. That should be 6x. And so the derivative itself is very nice. It's just got a constant on top, which is unequivocally nicer than what we saw, say, in the first step. Okay? So we are going to try and clean up those numerators. Moving on to the next page, find the slope of the tangent to blah, 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 where x equals negative 8. So this is a product rule. U is x to the 1/3. Okay? U prime is 1/3 x to the negative 2/3. V has a lot going on. And so it's 2x plus 15 squared. It's a glob squared, so I'm going to pull that power down front times the derivative, right? Because this is a glob. So it becomes glob to the 1 times derivative of the glob, which I think we should probably write this way. 4 by 2x plus 15. All right. So we're now ready to find the derivative. It's going to be 1/3 x to the negative 2/3 times 2x plus 15 squared plus u 1/3, that's the power of 1/3, times v prime. Now, you can simplify this as much as you want. It looks like enough of a mess that I'm just going to sub in some values. So this is going to be 1/3 -8 to the -2/3. And this will be 2 times -8 plus 15 all squared. So I'm just subbing in here in this first step. -8 to the +1/3. And then 4 times 2 times -8 plus 15. You can use square brackets if that helps. Let's see, how many did I open? I opened 3. Better close 3. Okay, so that's 1/3. -8 to the -2/3. So you got to take the cube root of -8, which is -2. You got to square it, which is +4. And you got to flip it over. So that's 1/4. 2 times -8 is -16 plus 15 is -1 squared. Next one, -8, its cube root is going to be -2. Okay, and that gives us 4 times. 2 times -8 is -16 plus 15 is -1. So let's see what we get here. That would be 1/12. And then we'll have plus 8. Okay, you can write that as 8 and 1/12. But in the next one, you're going to need to find the normal. So you probably want to write this in a form where it's easy to flip over. So 8 times 12 gives us 96 plus 1, so 97 over 12. Okay, and you do have that decimal to fraction button on your calculator. Maybe some people just put this in. But we do want to keep our answers exact because, at least in theory, we're doing this analytically. Okay, we want the equation of the normal, so that means we need a point and a slope. So the point is going to be -8 something or other. Okay. And to find the y value, we'd have to go cube root of -8 times 2 times -8 plus 15 all squared. We just sub it in the original because the original says y equals. So if we want a y value, that's our jam. So -2 times -1 squared, that would be -2 times 1, or -2. Bam, that's a point. The slope is going to be the negative reciprocal of the tangent slope. So it'll be -12 over 97. Okay. Now we're ready for point slope formula. Y minus y1, m x minus x1. And so that'll be y minus -2, so that's y plus 2. -12 over 97 by x minus -8. Okay, so that would be x plus 8. And so we get y plus 2. You've got full marks at this point. It doesn't specify the form. If we want to put it in y equals form, we'd have to be careful here. This is 8 over 1, so 12 times 8. Makes 96, unless I'm doing silly stuff here. And we'd have a minus, so minus 96 over 97. And then to bring that 2 over, we'd have to subtract 2 from both sides. I'll show that here, minus 2. I'm going to think of that 2 as -2 times 97 over 97. Or, I'm just stalling here to work this out in my head. Not that. 194 over 97. So again, you've got full marks at this point. And let's see what that's going to give us. -290 over 97. Okay. And honestly, given that you have access to the interweb, I would then go and actually graph this and make sure it looks like the equation of the normal at that point. It goes through at the point -2 or -8, -2, and it looks like it's perpendicular to the tangent. And lastly, find the x-coordinates where this is parallel to y equals 4x. So that's telling us that we're talking about a slope of 4, because that's just a line. So in other words, where does this function have a slope of 4? Well, f prime, the slope anywhere, is 3x squared plus 2x minus 1. Okay, so we can set this up. Oh my gosh, it's a quadratic. How exciting. I bet you folks are just as excited about that as I am. Now, you can factor it. Or guess what? You could use quadratic equation. It's totally up to you, quadratic formula, rather. But there we go. That has it factored. So where 3x plus 5 equals 0, or in other words, at negative 5/3, and at x equals 1, because that's where x minus 1 equals 0. Let's just go and check that one out quickly. So we can type in f of x, and then we can find f prime at x. And you can do this on your GDC too, using the dy by dx button. F prime, and we can just tell it about some numbers. What's the slope at 1? Tells us it's 4. We do the same thing. What's the slope at negative 5/3? Bam, it's 4. Okay, so we know we're correct. And those are the solutions to this test. There should be a blank and a filled-in version in the video description. I hope this has been helpful. Good luck with the material, and take care, folks.